Quadrilaterals. Quadrilaterals. A closed plane figure made up of the four line segments which will not intersect each other except at their endpoint is called a quadrilateral. Quadrilateral is derived from two words quadri, which means four, and lateral, which means side. Vertex, sides, angles, and diagonals of a quadrilateral. Suppose we have a quadrilateral ABCD. The point where the line segments meet is called vertex. The points A, B, C, and D are the vertices of the quadrilateral ABCD. The four line segments AB, BC, CD, and DA, which form a quadrilateral, are called sides of the quadrilateral. The four angles, angle DAB, angle ABC, angle BCD, and angle CDA are called its angles. A line segment joining two non-consecutive vertices is called a diagonal. In quadrilateral ABCD, AC and BD are the diagonals of the quadrilateral. Adjacent sides and opposite sides of a quadrilateral. Adjacent sides. Two sides of a quadrilateral are adjacent sides if they have a common vertex. In quadrilateral ABCD, pairs of adjacent sides are: number 1, AB and AD having A as a common vertex. Number 2, AB and BC having B as a common vertex. Opposite sides. Two sides of a quadrilateral are opposite sides if they do not have a common vertex. In quadrilateral ABCD, AB and DC, BC and AD are pair of opposite sides. Adjacent angles and opposite angles in a quadrilateral. Adjacent angles. Two angles having a side of quadrilateral in common are adjacent angles of quadrilateral. In quadrilateral ABCD, pairs of adjacent angles are: number 1, angle A and angle B having AB as common side. Number 2, angle B and angle C having BC as the common side. Opposite angles. The two angles of a quadrilateral that do not have a common side are called its opposite angles. In quadrilateral ABCD, angle A and angle C, angle B and angle D are pairs of opposite angles. Angle sum property of a quadrilateral. This property states that the sum of four angles of a quadrilateral is 360 degrees. It can be proved as: first, divide the quadrilateral ABCD into two triangles by drawing its diagonal DB. Since the sum of angles of a triangle is 180 degrees, hence the sum of angles of two triangles is equals to 2 into 180 degrees, which is equals to 360 degrees. Thus, it is proved that the sum of angles of quadrilateral is equals to 360 degrees. Interior angles of a quadrilateral. In a quadrilateral ABCD, the angles which are lying inside the boundary of a quadrilateral are called the interior angles. For example, angle 1, angle 2, angle 3, and angle 4 are interior angles of the quadrilateral or angles of the quadrilateral ABCD. Exterior angles of a quadrilateral. If the sides of a quadrilateral are produced in an order, then the angles which are formed outside the region of quadrilateral are called the interior angles of a quadrilateral. For example, angle X, angle Y, angle Z, and angle T are exterior angles of the quadrilateral ABCD. Exterior angles sum property of a quadrilateral. This property states that if the sides of a quadrilateral are produced in an order, the sum of the four exterior angles so formed is 360 degree. It can be proved as: let ABCD be a quadrilateral whose sides are produced in an order forming exterior angles x, y, z and t, and the angles 1, 2, 3 and 4 are interior angles. As we know that the sum of the angles of a linear pair is 180 degree. Proof: in quadrilateral ABCD we have angle x plus angle 1 is equals to 180 degree. Let's consider it as equation number 1. Angle y plus angle 2 is equals to 180 degree as equation number 2. Angle z plus angle 3 is equals to 180 degree as equation number 3. And angle t plus angle 4 is equals to 180 degree as equation number 4. On adding equation 1, 2, 3 and 4, we get angle x plus angle 1 plus angle y plus angle 2 plus angle t plus angle 4 plus angle z plus angle 3 is equals to 180 degree plus 180 degree plus 180 degree plus 180 degree, or 720 degree. Since the sum of angles of a quadrilateral is 360 degree, or on substituting angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 360 degree, we get angle x plus angle y plus angle z plus angle t plus 360 degree is equals to 720 degree, and angle x plus angle y plus angle z plus angle t is equals to 360 degree. Thus, it is proved that the sum of four exterior angles of a quadrilateral is 360 degree. Let's take an example of quadrilaterals. If the four angles of a closed figure are 125 degree, 80 degree, 95 degree and 60 degree, then check whether the figure is quadrilateral or not. Solution: let the four angles of a closed figure be angle A, angle B, angle C and angle D. It is given that angle A is equals to 125 degree, angle B is equals to 80 degree, angle C is equals to 95 degree and angle D is equals to 60 degree. As we know that the closed figure will be a quadrilateral only if angle A plus angle B plus angle C plus angle D is equals to 360 degree. Now, angle A plus angle B plus angle C plus angle D is equals to 125 degree plus 80 degree plus 95 degree plus 60 degree is equals to 360 degree. So, the figure is a quadrilateral.